Okay, where did my other, so one of these cameras should be just, I think it says Augustinelli, that's it, right there. Okay, spotlight video. Okay, very good. Is it turning sideways for you guys too? Ugh. Ah!
Mine is, I just rotated my screen.
Can you tell people how to do that? Because I wanted to get started on this. You mean you just turned it, or you actually hit a button that rotated it?
Yeah, on Chromebook, there's a certain method that you can use, which is just Control-Shift-Reload.
Control-Shift-Reload. Okay, good. So everyone hear that? So hopefully you guys can get it to come out right. I don't know why, but the stupid iPad, if you start it the wrong way, it stays the wrong way. Now I won't probably, well, let me see. I'll try to bring this over into chat, but I don't know if I'll be able to. It might mess up the sound. Okay, let me make sure you can still hear me. Okay, now, can you guys hear me? Mason, could you nod yes if that's the case?
Yeah.
Okay. I'm sensing an echo. All right. So hopefully you guys can hear me. Ellie, could you nod yes if you can hear me? Okay, thank you. I can only see some of you guys. All right, so what we're looking at here is our Lichtenberg burner, okay? Lichtenberg burner. Now we've got a plug. Now you guys will actually be able to understand some of this stuff now because we've been starting the robotics and the electronics. So we've got this plug that comes out of the, we've got this plug that's coming out of the wall here, and it's 120 volts, okay? So that's 120 volts. This is the one you're used to. That's right out of your wall, okay? Same one. We're gonna plug this in, and that's gonna bring 120 volts into our machine, into our Lichtenberg burner. If we follow that electricity, the electricity will come up through this cord here, go into this machine here, and then this machine is going to convert it. So where we had 120 volts from the plug, for this thing we need 12,000 volts. Okay, so it's going to bump this thing up quite a bit. So yeah, it produces 12,000 high voltage. Okay,
So then it's right?
We're dead. Somebody say something?
So is it a transformer then?
Yes, you are exactly right. So my next question was going to be, how does it do that? How does it transform the electricity from 120 volts into 12,000? And yes, the correct answer is it uses something called a transformer. Okay, so it's going to bump the voltage up to 12,000 volts. So as you can see here, I'm going to be using these safety gloves because they're going to keep me safe. These protect up to 20,000 volts, supposedly. Okay. Now they do come from China, and we always want to be suspicious of stuff we get from over there. Make sure it is actually up to the rating. But these are protecting up to 20,000 volts, and so we should be good because I always like to give a little bit of cushion. Okay. Now, what I'm going to be conducting electricity through is this piece of wood. But wood is not supposed to conduct electricity, right? Because wood's a what?
Insulator.
Insulator is the correct answer. Good job. So this is not supposed to conduct electricity. So that's why we had to bump the voltage up. Because remember, voltage is pressure, And the harder I can push electricity, the more I can get it to do things it doesn't normally want to do, like jump through the air or push through an insulator. Because an insulator resists electrical flow, but if you give enough electricity, you can usually overcome it. Okay, so I'm going to put my safety glasses on here. Now, I've got this mixture here. It just looks like water, so there's nothing really to see, but it's water and baking soda. And I'm going to mix it all over this wooden board here. And that's going to make this thing more electrically conductive. So I'm going to slop a fair amount of water on here because I know the wood is dry and it'll just soak it up real quick. And then I'm going to wipe off the excess water because I don't want water to like run over the table, touch my legs, and then I start shocking myself. So we're going to just keep the water on the table there. And I'm going to turn off the walkie-talkie because it never fails. Whenever we start doing this lecture, somebody starts yakking on there forever. Okay, so we've got our wood. We know it's an insulator. We put some water on it to hopefully conduct the electricity a little more. You're not supposed to have it soaking wet, so probably hard to tell on camera, but it's just damp, okay? It's just damp. It's not super soaking wet or anything. Okay, I'm gonna dry my hands off, and then we're gonna use these two probes here. One's gonna be the positive, and one's gonna be the negative. And the electricity is gonna try to jump from one of these probes to the other. Try to get it closer so you can see. Electricity is going to try to go between them. But since this is an insulator, it's going to have a hard time. And so we're using a lot of voltage to force it to go through. Okay? So I'm going to try to do this without shocking myself because we do not want to get hit with 12,000 volts of electricity. So I'm going to put my gloves on. I've got rubber-soled shoes on. And I'm going to sit down so that I don't get too jittery. And there's a little gas pedal on the floor here. And that gas pedal will control the wood burner. Let's see if I can zoom this in a little bit. Of course, it's not letting me zoom, so I will try to just get closer. Oh, stupid camera won't hold up the weight of this giant iPad.
Do you need me to run over there real quick? I know we're at the end.
Are you close?
I'm in the library.
Okay. Yeah, that'd be good.
Okay.
Thanks, Angela. Yeah, I'd like to. Oh, man. Okay. All right. Angela will be here in a second. And then I'd like you to get a close-up of it because it looks really cool. No. just got stuck with it. You can hold it here. I just got stuck with a parent email forever, so I didn't have as much sit-in time as I wanted. All right, so Angela will kind of zoom in. I think you can, well, you might be able to see it where you're at too. All right, so let's try this thing out. Now, Angela, if I start twitching from the electricity, don't touch me. Just use your foot and kick me over, okay? Because we don't want Angela to touch me because then she'd get shocked too. So let's try it close first. So right now it's on, and you're going to start seeing the electricity trying to jump. You can see it burning its path there. It's kind of following the grain lines, but it's trying to get back to the other probe, and it's finding the path of least resistance, which is often very surprising. See how it just connected there? So I'm going to turn that off. We'll try a longer one here.
You want me to turn it?
Whatever gives you the best. So it's starting to burn. You can see it's starting to make its way through the wood, and the electricity is finding that path of least resistance.
It would try to get it to turn for them, but
I know, the thing is such a nightmare. It's so annoying. You can see it burns these really cool, intricate electrical patterns. It kind of looks like coral reefs or Japanese maple trees, like cutting a bonsai or something.
how do I get it to it?
You can see it slowly making its way across. Very, very cool effect here.
That was really cool.
It's just about to connect, and bang. And then what'll happen is, since it's got one path now, it's going to start burning that path even more. You can see it kind of glowing. Looks like a little river of lava kind of thing. And so it burns it more, and it makes it deeper and deeper and deeper. So I'll do one more, and then we'll call it for today. But this is the Lichtenberg burner, and you're seeing lots of the principles that we've been learning about. So this is a series circuit. You've got 120 volts coming out of the wall. You got a transformer. You got two electrical probes. You got conductors, insulators. And so we got a lot of the stuff that we've been talking about in electricity. And so you guys should have kind of a basic understanding of what's going on. And as we keep going, your understanding will grow more and more and more. You can see how it's going, all these weird circuitous paths. But nevertheless, that's the one of least resistance. So very, very cool looking stuff.
That was cool.
And in the woodshop classes, that's a project you can actually do, is use that to make your project cooler. So I'm gonna turn those off, and remember, when we get lots of resistance like that, we also get lots of heat. So we gotta be careful of burns.
You want it?
Yeah, I don't know how these things work.
How do we get that to?
All right, guys. So anyways, I'm gonna kill it there for today. You guys are free to go. I just wanted to show you that Lichtenberg burner and give us a little bit of electrical basics, okay?
See ya. How do we get that to flip?
I don't know.